21, Saudi Crown Prince Mohammed bin Salman released a video announcing bold plans for the future. It was a keynote speech that looked all too familiar, a lot like the late Steve Jobs announcing a new smartphone era.
We're introducing 3 revolutionary products at this conference.
Yet instead of big tech, it's all about futuristic urban development and utopian nation building. The plans are ambitious. A linear city stretching 170 kilometers with no roads, no cars, and no pollution. This so-called civilization revolution will house over 1 million people. But there's one major point that wasn't addressed in the speech. A city of this size needs water, a lot of it. And we're talking about one of the driest places on Earth. Water scarcity is ubiquitous in the Middle East. In fact, while a global water crisis is looming over many countries, it's affecting this region more than most. Exponential population increases and environmental impacts have led to the tricky situation of growing demand for an ever scarcer resource. To mitigate the problematic consequences, countries in the region have predominantly relied on an expensive and highly controversial measure: desalination.
Stage, the water is then pumped as distillate water and then...
The principle of the man-made desalination process is simple. You suck seawater out of the ocean, separate it from its salt, and deliver the fresh water wherever it's needed, mostly for human consumption or irrigation. Until now, there have been 2 main ways of doing this. Thermal desalination is the more traditional method, involving heating up salt water and then cooling the vapor to make fresh water. The other, more sophisticated and dominant technology on the market is called reverse osmosis. Using high pressure, salt water is pushed through a semi-permeable membrane to separate the salt. RO membrane systems typically use less energy than thermal desalination. However, both methods still come at a huge cost, both economical and environmental. The economic costs stem from the high energy demands of desalination, which are linked in turn to a global environmental cost dependent on how the energy was produced. In the Middle East, this mainly means fossil fuels. Desalination plants are responsible for a combined output of 76 million tons of CO2 per year, a number that's expected to be almost 3 times higher by 2040. On a local scale, the main issue is the byproduct of desalination, hypersaline brine. After extracting fresh water, the brine is usually pumped back into the ocean. As it's much denser than seawater, it sinks to the bottom, where it can damage ecosystems by spiking salt content and causing oxygen levels to plummet. All this means that countries traditionally only resort to desalination if there are simply no alternatives available, or they need to become independent from a regionally disputed water source. Egypt, for example, is betting heavily on expanding its desalination industry due to rapid population growth and growing fears of Nile River droughts. Desalination is meant to ease tensions with upstream Ethiopia over the massive Gerd Dam project and to fill the already existing gap. Across the border, in Israel, drought and overpumping have brought the biblical Sea of Galilee to an extreme low. The inland sea is Israel's biggest freshwater reservoir, and its low level is now starving the downstream River Jordan and the Dead Sea. Prime Minister Benjamin Netanyahu's government sees the solution in desalination. The intention is to pump desalinated water from the Mediterranean to the Sea of Galilee and simply refill it. Desalination is booming. The number of seawater desalination plants in operation worldwide has more than doubled since the early 2000s. Today, more than 300 million people globally get their water from this technology. A total of 173 countries run desalination plants, but the leader of the pack is without doubt Saudi Arabia. By far the largest of the few countries in the world without a single river, its coasts are densely stocked with desalination plants. Together, they produce more fresh water than any nation, a fifth of the world's total. At Al Jubail, the world's largest desalination plant produces more than 1.4 million cubic meters of water a day and provides the country's capital with fresh water. With very little fresh water at its disposal, yet awash in oil money, Saudi Arabia uses fossil fuels to generate the vast amount of electricity needed. The country also has to cope with huge amounts of waste from this energy-intensive industry. Under current RO technology standards, it takes 2 gallons of seawater to make a gallon of fresh water. The gallon left behind is brine, pumped back into the ocean. But all this is supposed to change. NEOM is Saudi Arabia's ambitious flagship giga-project, a $500 billion investment in a country within a country, located in the sparsely populated northwest, along the shores of the Red Sea. Among its key concepts are sustainability and environmental responsibility. But what's the substance behind these fancy catchphrases when it comes to supplying the huge demand for a scarce resource like fresh water in the desert? The solution is supposed to be an innovative technology that looks like this: a sphere formed by a glass and steel dome rising 25 meters into the air, which covers a cauldron of roughly the same size. The so-called solar dome was developed by the UK-based company Solar Water in association with Cranfield University. The theory behind it is actually quite simple. Seawater is piped through a glass-enclosed aqueduct system, which heats the water with sunlight as it travels into the dome. An array of parabolic mirrors concentrates the solar radiation onto the dome. This superheats the seawater in the cauldron, where it evaporates. As a result, highly pressurized steam is released and condenses as fresh water, which is then piped to reservoirs and irrigation channels. The solar dome is meant to produce 30,000 cubic meters per hour at an extremely low cost of 34 cents per cubic meter. All of it 100% carbon neutral. But there's still the issue of the hypersaline brine. Supposedly, the desalination process in NEOM reduces the total amount of brine created during water extraction, helping to prevent damage caused to marine life by not discharging any brine into the sea. Yet so far, the question of what really happens to the concentrated brine is still unanswered. Solar Water alleges that it can be extracted and sold commercially. The brine contains substances that can be put to good use in other industrial processes. It still remains to be seen whether this actually works, and whether the plan to create a commercially viable extraction of resources for other industries will succeed. The first solar dome is currently under construction, to be trialed on an industrial scale. NEOM's solar desalination project will serve as a test case for other water-scarce countries that are struggling to generate environmentally safe and sustainable sources of fresh water. Solar Water's vision is bold: carbon-neutral agriculture and reforestation in the middle of the desert. It's hard to predict how much of this vision will turn out to be true. NEOM will certainly put it to the test, with the first solar dome desalination plant planned for completion in 2021. Desalination, despite all its issues, isn't going anywhere. As it gets cheaper and water scarcity becomes ever more threatening, the industry will continue to grow, and countries in the Middle East will rely on it totally. It's up to all of us to handle the valuable resource of fresh water in a saving and sustainable manner.